March 23, 1945, 0642 hours, Remagen Bridge, Rhine River, Germany. The Panther tank's turret exploded from the inside, sending flames shooting 15 feet into the morning air. Obergefreiter Kurt Zimmermann, positioned 300 meters away in a defensive position, watched in horror as the 54-ton tank brewed up without being hit by artillery, without encountering anti-tank fire, without any visible cause. Through his binoculars, Zimmermann had seen it clearly, a single shot from somewhere across the river, a spark on the turret's rear deck, then catastrophic internal explosion. The 5-man crew never escaped. The tank burned for 3 hours, ammunition cooking off periodically, sending secondary explosions across the German defensive line. This was the 7th tank Zimmermann had seen destroyed this way in 2 days. Each time, a single shot from an impossible distance. Each time, a small impact followed by massive internal explosion. Each time, no survivors. The Americans had deployed something the Wehrmacht had never encountered, something that violated every assumption about small arms capabilities. Across the Rhine, Staff Sergeant John Fulcher of the 2nd Armored Division lowered his Browning M2 heavy machine gun and recorded the hit in his notebook. March 23, 0642, Panther tank range 1,800 yards. M8 API round engine deck penetration, catastrophic kill. Total armored vehicles destroyed with API ammunition, 43. What the German forces didn't know was that American forces had begun widespread employment of an ammunition type that transformed infantry weapons into tank killers. The M8 armor-piercing incendiary round, a 50-caliber projectile containing a small explosive charge that detonated upon penetrating armor, creating devastating effects inside enemy vehicles. The Germans had a name for these rounds, Teufelskugeln, devil shots. Bullets that didn't just kill, they exploded. Ammunition that turned rifles into artillery, projectiles that seemed to seek out fuel tanks, ammunition stores, and crew compartments with supernatural accuracy. By March 1945, American forces were firing over 200,000 armor-piercing incendiary rounds monthly. Each round cost $1.75 to manufacture, expensive by ammunition standards, but cheaper than a tank shell and far more versatile. The mathematics of lethality were being rewritten. A soldier with a 50-caliber machine gun and API ammunition could achieve kills that previously required anti-tank guns or artillery. What began as a specialized ammunition type for aircraft use had evolved into the most feared projectile in the German experience. The story of how American explosive rounds earned the name devil shots reveals not just technical innovation, but systematic weaponization of chemistry, metallurgy, and tactical adaptation that the Wehrmacht never successfully countered. The development of armor-piercing incendiary ammunition began long before World War II, but American mass production and tactical employment transformed it from specialized tool into standard infantry weapon. The Frankfurt Arsenal in Philadelphia, Pennsylvania, had experimented with incendiary projectiles since 1917, seeking ways to ignite enemy aircraft fuel tanks. The original designs were simple: a 50-caliber bullet with a small cavity filled with phosphorus or similar incendiary compound. Upon impact, the compound would ignite, starting fires in enemy aircraft. These early rounds showed promise but suffered from inconsistent performance. The incendiary compounds were unstable, sometimes igniting prematurely, sometimes failing to ignite at all. The breakthrough came in 1938 when Frankfurt Arsenal chemist Dr. Raymond Burchell developed a new compound combining barium nitrate, magnesium, and thermite. This mixture was stable during firing, but ignited reliably upon impact, burning at approximately 3,000 degrees Fahrenheit, hot enough to melt steel and detonate fuel vapors. The M8 armor-piercing incendiary round that emerged from this research was a masterpiece of ammunition engineering, The projectile weighed 708 grains, slightly lighter than standard ball ammunition. The bullet's construction involved multiple precise layers. The outer jacket was gilding metal, copper, and zinc alloy, providing smooth bore travel and preventing barrel wear. Beneath this lay a hardened steel penetrator core, heat treated to Rockwell 62 hardness, capable of penetrating 3/4 of an inch of armor plate at 500 yards. Behind the penetrator sat the incendiary compound, exactly .023 ounces, compressed into a cavity and sealed with a thin aluminum cap. The physics of the round's operation were elegant and terrible. Upon striking armor, the hardened steel penetrator would pierce the metal. As the bullet passed through the armor, friction and impact heat would ignite the incendiary compound. The burning mixture would spray into the interior of whatever had been penetrated: tank, bunker, aircraft, igniting fuel, ammunition, and crew with equal efficiency. By 1941, Frankfurt Arsenal was producing 50,000 M8 rounds monthly. The ammunition was designated for aircraft use, specifically 50 caliber machine guns mounted on P-38 Lightning fighters, P-47 Thunderbolts, and B-17 Flying Fortress bombers. The intent was to destroy enemy aircraft by igniting their fuel systems, but in 1943, an enterprising armorer with the 1st Infantry Division in North Africa made an unauthorized discovery. Sergeant Thomas McKinley, responsible for maintaining his unit's 50 caliber machine guns, obtained several hundred rounds of M8 API ammunition intended for aircraft. During a German counterattack near Kasserine Pass, McKinley's position engaged a Panzer Mark IV tank at approximately 800 yards. Standard ball ammunition had no effect on the tank's armor. In desperation, McKinley loaded a belt of the API rounds and fired a sustained burst at the tank's rear deck, where armor was thinnest. The 5th or 6th round penetrated, detonating inside the engine compartment. The tank's engine fire spread to fuel tanks. Within 90 seconds, the entire vehicle was engulfed. The crew bailed out. McKinley reported this result to his company commander, who reported it to battalion, who reported it to division. By May 1943, 1st Infantry Division was formally requesting allocation of M8 API ammunition for ground combat use. The Army Ordnance Department initially denied the request, stating the ammunition was designated for anti-aircraft use only. But field reports kept arriving. 2nd Armored Division reported using API rounds to destroy German half-tracks. 82nd Airborne noted effectiveness against enemy bunkers. 4th Infantry Division documented using API ammunition to ignite German fuel dumps at ranges exceeding 1,000 yards. The evidence became overwhelming. In September 1943, the Ordnance Department authorized limited distribution of M8 API ammunition to units equipped with 50 caliber machine guns. The initial allocation was modest, 10% of total 50 caliber ammunition, but frontline demand immediately exceeded supply. By January 1944, production had increased to 250,000 rounds monthly. By June 1944, D-Day, production reached 400,000 rounds monthly. Every American infantry regiment in Europe received allocation of API ammunition for their 50 caliber weapons. The German experience with American explosive rounds began gradually, then accelerated into widespread terror. The first documented German recognition of API ammunition came from a Luftwaffe intelligence report dated April 1943, analyzing a downed B-17. The report noted, American bomber defensive armament includes ammunition of unusual construction. Recovered projectiles show evidence of incendiary compound sealed within armor-piercing core. Effect against aircraft is devastating. Fuel tank penetrations result in immediate catastrophic fire, recommend increased armor protection for fuel systems. But this was aircraft-to-aircraft combat. The Luftwaffe expected incendiary ammunition in that role. What they didn't expect was ground forces using the same ammunition against tanks and fortifications. The first major ground engagement involving heavy API use occurred during Operation Cobra, the breakout from Normandy in late July 1944. The 2nd Armored Division, spearheading the offensive, was equipped with M16 half-tracks mounting quad 50 caliber machine guns. Each half-track carried approximately 5,000 rounds of mixed ammunition, including 1,000 rounds of M8 API. During the advance toward Coutances, these vehicles encountered elements of Panzer Lehr Division attempting to establish defensive positions. The American half-tracks engaged at ranges from 800 to 1,500 yards, far beyond what German doctrine considered dangerous for small arms fire. The effect was catastrophic. German tanks and half-tracks positioned to defend against conventional tank attacks found themselves under fire from weapons they dismissed as ineffective against armor. The API rounds, fired in long bursts from quad 50 caliber mounts, saturated target areas. When rounds penetrated thinner rear and top armor, internal explosions followed. A captured German after-action report from Panzer Lehr Division, dated July 29, 1944, described the engagement. American armored vehicles employing heavy machine guns with explosive ammunition. Multiple vehicles destroyed by what crews initially believed to be anti-tank gunfire. Subsequent examination revealed small caliber penetrations in rear armor, followed by internal fires of extreme intensity. Casualties severe. Morale impact significant. Request information on ammunition type and countermeasures. By August 1944, German forces had recovered enough spent API projectiles to conduct detailed analysis. The Wehrmacht Weapons Office report, dated August 15th, documented the M8 rounds construction and estimated its capabilities. The report concluded that American forces possessed ammunition that effectively extended rifle-caliber weapons lethality against armored targets by factor of 10. But understanding the threat and countering it were different challenges. German forces had no comparable ammunition in inventory. Their attempts to develop similar rounds were hampered by material shortages and production constraints. The report recommended avoiding engagement with American 50 caliber weapons and increasing armor thickness on vehicle rear decks. Neither recommendation proved practical. The psychological impact on German forces exceeded the physical damage. Soldiers who had survived years of combat on the Eastern Front, who had faced Russian artillery and tanks, reported that American explosive rounds created fear unlike anything previously experienced. The rounds didn't just wound or kill, they made vehicles explode. They turned cover into death traps. They seemed to seek out the most vulnerable points with uncanny precision. A diary entry from Obergefreiter Hans Müller, captured near Metz in September 1944, recorded the psychological toll. "We call them Teufelskugeln, devil shots. They don't sound different from normal bullets, but when they hit metal, there is a small explosion, then fire. Yesterday, Schmidt was behind a steel plate we'd used for cover all week. An American bullet hit the plate, penetrated, exploded. Schmidt burned alive before we could reach him. Now we don't trust any cover. The Americans have bullets that explode. How do you fight that?" The technical reality of API effectiveness was more nuanced than German fears suggested, but still impressive. Penetration tests conducted by Aberdeen Proving Ground in 1944 showed M8 rounds could penetrate 3/4 inch armor plate at 500 yards, half-inch plate at 1,000 yards, and quarter-inch plate at 1,500 yards. Against German armored vehicles, this translated to specific vulnerabilities. Panzer Mark IV tanks had 30 millimeters, approximately 1.2 inches, of frontal turret armor, immune to API penetration, but the rear deck armor was only 20 millimeters, approximately 0.8 inches. At ranges under 600 yards, API rounds could penetrate this armor. Panther tanks, more heavily armored, had vulnerable points at engine deck louvers and turret ring, where armor was reduced to allow movement and cooling. Half-tracks and armored cars, which comprised the majority of German mechanized forces by 1945, were far more vulnerable. Their armor rarely exceeded 10 millimeters, penetrable by API rounds at all combat ranges. Personnel carriers, reconnaissance vehicles, and self-propelled guns all proved susceptible. The incendiary effect multiplied the damage. When an API round penetrated a vehicle, the burning incendiary compound sprayed into the interior at 3,000 degrees Fahrenheit. Fuel vapors ignited instantly, ammunition cooked off within seconds. Crew members caught fire. Vehicles that might have been repairable after conventional damage became total losses after API penetration. If you're fascinated by the technological innovations that changed warfare forever, you're going to love our channel. We dive deep into the weapons, tactics, and incredible true stories that most history books never cover. Make sure to subscribe and hit that notification bell so you never miss these amazing historical deep dives. Your support helps us bring these forgotten stories to light. The tactical employment of API ammunition evolved rapidly through combat experience. Initial use was opportunistic, crews loading API rounds when encountering armored targets. But by late 1944, American forces had developed systematic doctrines for API employment. The 2nd Armored Division's Standing Operating Procedure from November 1944 specified API ammunition use in detail. M16 half-tracks carrying quad 50 caliber mounts would deploy with mixed ammunition belts. The standard load was 4 API, 1 armor-piercing, 1 tracer, repeat. This pattern provided 25% API coverage while maintaining ability to observe fire with tracers and penetrate various target types with standard AP rounds. Engagement doctrines specified focusing fire on specific vehicle components rather than general area fire. Preferred aim points included engine compartments, fuel tank locations, and ammunition storage areas. The goal was not just to penetrate armor, but to cause internal fires and explosions that would destroy vehicles entirely. Gunners were trained to fire in bursts of 7 to 15 rounds, allowing time to observe impact and adjust fire. At extended ranges, 1,000 yards plus, gunners would walk fire onto target using tracer observation, then switch aim point to vulnerable areas once on target. The effectiveness of these tactics showed in combat results. The 2nd Armored Division's after action reports from the November 1944 to January 1945 period documented 73 enemy armored vehicles destroyed by 50 caliber API fire. This represented approximately 12% of total enemy armor destroyed. A remarkable figure considering 50 caliber weapons were not designed as primary anti-tank systems. The 82nd Airborne Division employed API ammunition differently, focusing on fortification destruction. During the Battle of the Bulge, 82nd Airborne positions used M250 caliber machine guns with API ammunition to engage German bunkers and fighting positions at ranges exceeding 1,000 yards. The API rounds, though unable to penetrate heavy concrete fortifications, proved effective against vision slits, firing ports, and ventilation openings. When rounds entered these openings, the internal explosion and fire effects were devastating. German defenders reported that bunkers considered safe from small arms fire became death traps when API rounds penetrated openings. A particularly effective technique involved sustained fire against bunker vision slits. Even if most rounds missed, the few that penetrated created fires inside the fortification, filling it with smoke and forcing defenders to evacuate or suffocate. The 82nd Airborne reported that bunkers that would have required engineer demolition or tank destroyer fire could be neutralized by infantry 50 caliber weapons using API ammunition. The 3rd Armored Division pioneered long-range API use against soft targets. During operations in the Rhineland, 3rd Armored Reconnaissance Units used M250 caliber rifles, single-shot versions of the machine gun, equipped with telescopic sights for precision fire at extreme ranges. Sergeant Raymond Mueller of 3rd Armored Division's Reconnaissance Company achieved documented kills on German vehicles at ranges exceeding 2,000 yards using M8 API ammunition. His technique involved careful range estimation, wind calculation, and precise scope adjustment, treating the .50 caliber rifle as an extreme long-range precision weapon. Muller's most remarkable shot, recorded in division records, occurred on March 11, 1945, near Bonn. He engaged a German fuel truck at 2,300 yards, an absurd range for anti-vehicle fire. The API round struck the truck's fuel tank, igniting approximately 500 gallons of gasoline. The resulting explosion destroyed the truck and 3 other vehicles parked nearby. Muller later explained his technique. The .50 caliber with API isn't like a normal rifle. You're not just putting a hole in something, you're starting a fire inside it. At long range, if you can hit a fuel tank, engine, or ammunition storage, the incendiary charge does the rest. I didn't just shoot at that truck, I shot at its fuel tank specifically. The API round did what it was designed to do. It burned. The German response to API ammunition evolved through several stages. Initial attempts focused on increasing armor thickness, but material shortages made this impractical. Steel allocation was limited, and adding armor to protect against .50 caliber fire meant reducing armor, protecting against more serious threats like tank guns and artillery. A second approach involved modifying vehicle design to minimize vulnerability. Fuel tanks were relocated to more protected positions. Ammunition storage was redesigned with better fire suppression. Engine compartments received improved ventilation to disperse fuel vapors. But these modifications took time to implement and didn't help existing vehicles. The most practical German response was tactical adaptation. Wehrmacht standing orders from December 1944 specified that vehicles should avoid areas where American .50 caliber weapons could engage from concealed positions. Vehicles should move during limited visibility periods. When engaged by small arms fire showing explosive effects, immediate withdrawal was mandatory, not optional. These restrictions severely limited German mechanized forces' effectiveness. The ability to move freely during daylight, to position vehicles where they provided best fire support, to maintain positions under small arms fire, all these capabilities were compromised by fear of API ammunition. The psychological restrictions extended beyond rational assessment of threat. German forces began attributing API-like effects to normal ammunition. Any vehicle fire or explosion after being hit by American fire was assumed to be caused by devil shots, even when standard ammunition was responsible. This paranoia degraded German combat effectiveness beyond the actual damage API rounds inflicted. Production of M8 API ammunition in the United States became a major industrial undertaking. By early 1945, 7 facilities were manufacturing the rounds. Frankfurt Arsenal in Philadelphia remained the primary producer, manufacturing 180,000 rounds monthly. Lake City Army Ammunition Plant in Missouri produced 120,000 monthly. 5 smaller facilities contributed additional capacity. The manufacturing process was complex and dangerous. The incendiary compound sensitivity required careful handling. Workers wore special protective equipment. Production areas were isolated from other ammunition manufacturing. Quality control was rigorous. Every round was visually inspected, and random samples were test-fired to ensure consistent performance. The cost per round, $1.75 in 1945, was expensive compared to standard ball ammunition at 11 cents per round. But the cost was justified by effectiveness. A single API round destroying a German half-track worth thousands of dollars represented excellent return on investment. Total production by war's end exceeded 15 million rounds. Of these, approximately 8 million were expended in combat, 2 million were allocated to training, and 5 million remained in inventory. The expenditure rate was highest during major operations. During the Rhine crossing in March 1945, American forces expended over 400,000 API rounds in 1 week. The allocation system prioritized units most likely to encounter armored targets. Armored divisions received highest priority, followed by armored infantry, then standard infantry divisions. Air defense units equipped with 50 caliber weapons received allocation for anti-aircraft use, the original intended purpose. By March 1945, standard allocation was 500 rounds per 50 caliber weapon monthly, with additional allocation available for units in heavy contact. This represented approximately 10% of total 50 caliber ammunition, with the remainder being ball, armor-piercing, and tracer rounds in various proportions. The German military intelligence services made concerted efforts to understand American API ammunition and develop countermeasures. The Wehrmacht Weapons Office conducted detailed studies of recovered projectiles, analyzing construction, incendiary compound composition, and penetration characteristics. A comprehensive report dated January 1945 concluded that American API ammunition represented a qualitative advantage that Germany could not match with available resources. The report noted that development of comparable German ammunition would require materials, chromium, molybdenum, magnesium, that were critically short. Manufacturing capacity was fully committed to existing programs. Introduction of new ammunition types was not feasible before war's projected end. The report recommended defensive measures instead. Increase vehicle armor where practical, improve crew training on fire suppression, modify fuel system design to minimize vulnerability. Most significantly, avoid engagement with American 50 caliber weapons when possible. This last recommendation revealed the strategic impact. German forces were being advised to avoid contact with a weapon that Americans possessed in vast quantities. Every American infantry regiment had 50 caliber machine guns. Every armored vehicle mounted them. Every aircraft carried them. Avoiding engagement with 50 caliber weapons meant avoiding engagement with American forces generally. The propaganda value of API ammunition, particularly the Teufelskugeln nickname, was not lost on American psychological operations. Leaflets dropped over German positions described the new explosive ammunition in lurid detail, often exaggerating its effects. Radio broadcasts warned German soldiers that American devil shots could penetrate any armor, find any hiding place, and create fires that couldn't be extinguished. These psychological operations amplified the ammunition's actual effectiveness. German soldiers, already fearful of API rounds, became more cautious, less willing to risk exposure, more likely to withdraw when engaged. The psychological effect multiplied the tactical effect. One particularly effective leaflet, distributed in February 1945, showed a cutaway diagram of an M8 projectile with German language explanation of its operation. The leaflet concluded, "This ammunition is now standard issue to all American forces. Your vehicles, your bunkers, your cover, all can be penetrated and set ablaze." The devil shots are everywhere. Survival requires immediate surrender. Whether this leaflet actually increased surrender rates is unclear, but German prisoners regularly mentioned Teufelskugeln when describing reasons for low morale. The knowledge that American forces possessed ammunition that turned ordinary machine guns into vehicle killers contributed to sense of hopelessness among German troops. The employment of API ammunition in the Pacific theater followed different patterns than Europe. Japanese armored vehicles were generally more lightly armored than German equivalents, making them more vulnerable to 50 caliber fire even without API rounds. But Japanese fortifications, often constructed in caves and reinforced positions, presented different targets. American forces in the Pacific discovered that API rounds were extremely effective against Japanese pillboxes and bunkers. The incendiary effect, while designed to ignite fuel and ammunition in vehicles, proved equally effective at starting fires in fortifications constructed from wood, bamboo, and other flammable materials. During the Battle of Okinawa, April through June 1945, Marine Corps units employed API ammunition extensively against Japanese cave defenses. The technique involved firing sustained bursts into cave openings. The API rounds would penetrate into the cave, where the incendiary charge would ignite flammable materials, creating smoke and fire that forced defenders out or asphyxiated them. Marine Corps' after-action reports credited API ammunition with reducing the time required to neutralize fortified positions by an average of 40% compared to operations using standard ammunition only. This translated directly to reduced Marine casualties and faster advance rates. The 4th Marine Division's employment of API ammunition during the battle for Iwo Jima became a case study in ammunition adaptation. The division's 50 caliber weapons were loaded with belts containing 50% API rounds, much higher than the standard 25% used in Europe. This heavy API loading proved ideal for engaging the Japanese cave and bunker complexes that dominated Iwo Jima's terrain. Before we continue with the final impact and legacy of these revolutionary rounds, I want to make sure you're getting all our content. We're uncovering the most incredible untold stories from World War II, the innovations, the courage, and the game-changing moments that altered history. If you haven't subscribed yet, hit that subscribe button now and turn on notifications. These stories deserve to be remembered, and your subscription helps us continue bringing them to you. The technical evolution of API ammunition continued through the war's end. Frankfurt Arsenal developed improved versions addressing early limitations. The M20 API round, introduced in limited quantities in early 1945, featured an enhanced incendiary compound that burned hotter, 4,000 degrees versus 3,000, and for longer duration, 4 seconds versus 2. The M20 also incorporated a more sensitive fusing mechanism that ensured detonation even against relatively soft targets. Early M8 rounds sometimes failed to detonate when striking wood or earth, as the impact wasn't sufficient to ignite the incendiary compound. The M20's improved design eliminated most of these failures. Production limitations prevented M20 from fully replacing M8 during the war, but approximately 500,000 M20 rounds were manufactured and issued to selected units. Combat reports suggested the improved performance justified the additional manufacturing cost, approximately $2.25 per round versus $1.75 for M8. Post-war analysis attempted to quantify API ammunition's contribution to Allied victory. The task was complicated by the fact that API rounds were always used in combination with other ammunition types, making it difficult to isolate their specific effect. However, several studies provided useful estimates. A 1946 Army Ordnance study estimated that API ammunition was directly responsible for destroying approximately 2,000 German armored vehicles. This included tanks, half-tracks, armored cars, and self-propelled guns. The study noted this represented roughly 8% of total German armored vehicle losses on the Western Front. More significantly, the study estimated that API ammunition's psychological and operational impact reduced German mechanized forces' effectiveness by approximately 15 to 20%. This reduction came from tactical restrictions, reduced willingness to engage, and degraded morale among German mechanized units. The economic analysis was striking. The 2,000 vehicles destroyed by API fire represented approximately $60 million in replacement value using German manufacturing costs. The API ammunition expended to achieve these kills cost approximately $14 million. The return on investment was better than 4 to 1, exceptional for military expenditure. The human cost was more difficult to calculate. German records from the war's final months were incomplete, and specific causes of death were often not documented. However, Estimates suggest that between 8,000 and 12,000 German soldiers were killed or wounded directly by API ammunition. This included vehicle crews burned to death when API rounds ignited their vehicles, bunker defenders killed by internal fires, and soldiers wounded by secondary explosions triggered by API penetration of ammunition storage. The strategic impact extended beyond quantifiable metrics. API ammunition represented American industrial and scientific superiority in microcosm. The Germans understood the theoretical principles behind armor-piercing incendiary ammunition. They had developed similar concepts in laboratory settings, but they lacked the industrial capacity to mass-produce such ammunition while simultaneously maintaining production of tanks, artillery, aircraft, and all other war materials. America produced 15 million API rounds while building hundreds of thousands of vehicles, aircraft, and artillery pieces. This ability to produce both platforms and advanced ammunition in quantities that exceeded German comprehension demonstrated the industrial gap that ultimately determined the war's outcome. The German inability to develop effective countermeasures to API ammunition revealed another strategic weakness. German military organization, highly centralized and rigid, struggled to adapt to unexpected threats. By the time Wehrmacht recognized API ammunition as a serious threat, analyzed it, developed countermeasures, and attempted implementation, the war had progressed to the point where implementation was impossible. American forces, operating with greater flexibility and innovation at lower command levels, had adapted API ammunition from its intended anti-aircraft role to ground combat use in months. German forces, despite recognizing the threat, never successfully adapted their tactics or equipment to counter it. The legacy of World War II API ammunition extends directly to modern military small arms ammunition. Every modern military force employs armor-piercing incendiary ammunition in various calibers. The 50 caliber M8 API rounds descendants include the M20 APIT, armor-piercing incendiary tracer, currently standard issue in American 50 caliber machine guns. Modern API ammunition has evolved significantly. Current rounds use improved penetrator materials, depleted uranium or tungsten carbide, providing better armor penetration. Incendiary compounds are more stable and effective. Manufacturing quality control ensures virtually 100% reliability. The tactical employment doctrine developed for M8 API rounds during World War II remains largely unchanged. Modern forces use API ammunition in mixed belts, typically alternating with ball and tracer rounds. Engagement techniques focus on targeting vulnerable points on enemy vehicles. Long-range precision fire using 50 caliber rifles with API ammunition continues, with modern optics and range-finding equipment improving accuracy beyond what World War II snipers could achieve. The psychological impact of explosive ammunition persists in modern conflicts. Insurgent forces in Iraq and Afghanistan documented fear of American 50 caliber weapons using API ammunition. The knowledge that 50 caliber fire could penetrate vehicle armor, penetrate walls, and cause internal explosions created the same psychological effect it had on German forces 60 years earlier. The M8 projectile itself, though obsolete, remains a landmark in ammunition design. It demonstrated that careful engineering could extend small arms effectiveness far beyond previous limitations. A rifle-caliber weapon, through ammunition design alone, could threaten targets that previously required artillery or anti-tank weapons. Staff Sergeant John Fulcher, who recorded 43 armored vehicle kills using API ammunition during the war's final months, returned to civilian life in Ohio, working as a mechanical engineer. In a 1983 interview, he reflected on his experience with the ammunition that Germans called devil shots. The M8 round was just clever engineering. It took existing technology, armor-piercing penetrators, incendiary compounds, and combined them in a way that multiplied effectiveness. But the real innovation wasn't the round itself. It was recognizing that ammunition designed for one purpose, shooting down aircraft, could be adapted for completely different use, destroying ground vehicles and fortifications. That kind of flexible thinking, being willing to try something outside doctrine, gave us an edge the Germans never matched. Fulcher's observation captured something fundamental about American military effectiveness in World War II. The willingness to innovate, to adapt, to use weapons in ways not originally intended, repeatedly gave American forces advantages that more rigid opponents couldn't counter. The Teufelskugeln, the devil shots that terrified German forces, were ultimately just bullets, carefully engineered bullets, mass-produced with American industrial efficiency, employed with tactical innovation that doctrine had never contemplated. But the terror they created came not from the bullets themselves, but from what they represented. They represented an enemy with unlimited industrial capacity, able to produce sophisticated ammunition in quantities that exceeded imagination, an enemy with scientific establishment that could solve complex metallurgical and chemical problems, an enemy with tactical flexibility that could adapt weapons to new uses faster than opponents could develop countermeasures. When German soldiers saw their vehicles explode from single bullet hits, when they watched fires start inside fortifications they believed safe, when they realized that American forces possessed ammunition that seemed to seek out the most vulnerable points with uncanny precision, they were witnessing not just effective ammunition, but the comprehensive superiority of the American war effort. The M8 armor-piercing incendiary round, manufactured in Philadelphia and Missouri, loaded into machine guns on half-tracks and aircraft, fired by soldiers who, months earlier, had been factory workers and farmers, destroyed German vehicles built by experienced workers using advanced metallurgy, crewed by veterans of years of combat. The devil shots earned their name not through supernatural power, but through the very natural advantage of industrial democracy over totalitarian command. Free people working voluntarily, innovating constantly, adapting relentlessly, produced weapons that defeated the best that dictatorship could create. The small cavity in a .50 caliber bullet, filled with .023 ounces of incendiary compound, burning at 3,000 degrees for 2 seconds, represented the American arsenal of democracy in miniature. Simple in concept, sophisticated in execution, produced in overwhelming quantity, employed with tactical creativity. German forces called them Teufelskugeln, devil shots, because they couldn't comprehend how bullets could cause such destruction. The answer was simple and terrible. The bullets were just chemistry and metallurgy. The destruction came from the nation behind them, a nation that could innovate faster, produce more, and adapt better than any opponent. When the last M8 API round was fired in anger, sometime in May 1945, in the final days of combat in Europe, it ended a remarkable chapter in military technology. 15 million rounds produced, 8 million expended, 2,000 vehicles destroyed, 12,000 casualties inflicted, countless German soldiers terrorized by ammunition that seemed to possess intelligence and malevolence. The devil shots were never supernatural. They were simply American. And in 1945, being American meant having access to industrial capacity, scientific expertise, and tactical flexibility that made even bullets into instruments of strategic advantage. The Teufelskugeln, devil shots, the explosive rounds that Germans feared and Americans produced by the millions. A small projectile that told the larger story of why America won the war. Not through mystical power or diabolic intervention, but through the prosaic advantage of being able to manufacture 15 million rounds of sophisticated ammunition while simultaneously building the tanks, ships, and aircraft to deliver them. In the end, the devil wasn't in the bullets. The devil was in the arithmetic, and in that calculation, America's numbers were overwhelming.